In lesson 10.5, we are going to solve systems by linear equations, also known as elimination. Your objective is I will be able to identify the relationship between two graphs by using elimination. On this slide, there are steps. So you have 5 lovely steps to solving using linear combinations or elimination. You can go back and look at this through the PDF posted in Google Classrooms if you would like to reread it. I'm going to go ahead and show you some examples. Your first step is to arrange both equations so that you'll notice that the x's are on top of the x's, the y's are on top of the y's, and the terms without variables are right on lined up with each other. That's what they mean by arranging. This one already has a set of coefficients that will cancel out. That's the whole lesson for elimination. Okay, we are able to eliminate these because 3 positives and 3 negatives will cancel each other out. This will leave us with 6x equals 24, and now we know one-step equation divided by 6 on both sides, and that's how we get x equals 4. Let me go ahead and do one for you. If we look here, we notice that our x's are lined up, our y's are lined up, and our terms without the variables are lined up. If I notice, my x's are ready to cancel out. So all I have to do is add down my y's. So I have 2 y's plus 6 y's, and I'm left with 8 y's equal negative 8 minus 16 is negative 24. Go ahead and divide by 8 on both sides, and you're left with y equals negative 3. If you remember correctly, when we solve a system of equation, we want to know where do they intersect, so an x comma y. So what I'm given is a y value. I need to solve for my x now. So I'm going to go back and I'm going to choose to use this equation. So the x plus 6y equals negative 16 to solve for y. It's a different color here. I'm going to plug in negative 3. Down here I got negative 3 for y. I'm going to plug that in. So I have x plus 6 times negative 3 equals, negative 16, because that's in the given problem. I'm left with x minus 18 equals a negative 16. One-step equation here, add 18 to both sides, and I'm left with x equals 2. So now I have my x value, and I have my y value. Now that I know where these two lines intersect, I can write my coordinate point 2, comma negative 3, and that is my systems for these two linear equations. Sometimes you're going to have to set up. Notice here we have our x's lined up, our y's lined up, and our terms without variables lined up. But notice none of the x's and y's are set up easily to cancel out. So what you have to do is multiply one or both of the equations in order to cancel out a variable. So with this, in this example, they chose to use the 3x and the 4x because one was already negative, so it just helped. So they multiplied the top equation by 4 because they wanted to get 3 to be 12. And they multiplied the bottom equation by 3 because they wanted that negative 4 to become negative 12 so that it will then cancel out. Okay? Don't forget, whatever you choose to multiply the one term by, you have to multiply all terms. So every term in the top equation was multiplied by 4. Every term in the bottom equation was multiplied by 3. Then our 12x minus our 12x cancels out, and we just add down for the other two sets of terms. So 20y plus 6y equals 26y, and then 24 plus 15 equals 39. One-step equation, they divided by 26 on both sides, and they were left with y equals 1.5. So that of their coordinate point, 1.5, is that. Now to solve for x, they plugged in 1.5 for y. solved for x, and they got negative 0.5. And that is that solution of that system of equations. Let's go ahead and do an example here. Now notice that I have 5x and 2x. I have negative 4y and a positive 8y. I have a 13 and a negative 2. I'm going to work with this set right here. Oops. This set right here to get those to eliminate. Because what's awesome about this is I only have to multiply one equation. Because if I multiply 4 by 2, I will get it to 8 and it will already be ready to go. So I'm going to multiply this top equation by 2. And I'm going to get 10x. Remember, you multiply it to every term. 10x minus 8y equals 26. Now I don't need to multiply my bottom equation by anything because I already have a positive 8y and it will cancel out the negative 8y. So I'm going to rewrite that. 2x plus 8y equals a negative 2. Then I'm just going to add down. So I'm 10x plus 2x is 12x. This right here, I'll show you with a different color, negative 8y plus 8y cancels out. So I am now left with 12x equals 24. One-step equation, divide by 12 on both sides, x equals 2. Now that we've solved for x, we can go ahead and plug our x in for one of the equations and then solve for y. So I'm going to choose to use the 2x plus 8y equals negative 2. No real reason. I could have used the top one if I wanted to. I just chose this one. So now I have 2 times 2 plus 8y equals a negative 2. Let me show you what I did here. I took this 2 and plugged it in to the x value because that's what x equaled. Now I'm just going to go ahead and solve for y. So 4 plus 8y equals a negative 2. Subtract 4 from both sides. 8y equals a negative 6. Divide by 8. We can go ahead and simplify this so it becomes y equals negative 3/4. So now that's our y value. Now remember, systems of equations, a solution is written in x comma y form. X comma y form for our solution. So here our answer is 2 comma negative 3/4. And what this tells me is where the two lines intersect. This is the coordinate point at which the two lines, these two lines right here, these two lines right here, tells me where those two lines intersect on a coordinate grid. In this example, it's just showing you that if you notice that your columns are not aligned, so you'll notice that right here your x's aren't aligned. We need to arrange those. So all you'll do is move things over, move things around. What they chose to do here is move this 5x to the other side, and then you solve just like you would on the other examples. So for this example, I want to move this 6y to the other side. So I'm going to add 6y to both sides. They don't add up together because they're not like terms. So it becomes 3x plus 6y equals 12. Now what I notice is I have the minus x plus 3y equals 6. So now these are my two equations that I'm working with. This bottom equation needs to have a common term to cancel out. So I'm going to multiply it by 3. And I will be left with, I'm going to go ahead and write up here. So I'm going to rewrite the one that I'm not messing with. So 3x plus 6y equals 12. Sorry for my sloppy handwriting. And then I'm going to multiply this number to each term, distributive property. So I'm left with negative 3x plus 9y equals 18. And I'm going to go ahead and solve down. You will notice that this 3x minus 3x cancel out. So I'm left with 15y equals, let's see, that becomes 30. Divide by 15 on both sides. Y equals 2. Go ahead and plug that into one of the original equations. Let's see, we can plug it into the 3x equals negative 6y plus 12. I'm going to plug it in for, I'm going to plug in 2. I'm going to take this 2 right here, and I'm going to plug it in for that y value up there. So I'm left with 3x equals negative 6 times 2 plus 12. 3x equals negative 12 plus 12. 3x equals 0, because negative 12 plus 12 cancels out. Divide by 3. X equals 0. So you will notice now that I have my solution. My y is 2. My x is 0. I'm going to go ahead and put it in a coordinate point to show that that is my solution. So my solution of this system of equation is 0, 2. And what that means is this is where these two lines intersect. And that is it for lesson 5.